Hey there, welcome back to the notes for Chapter 1. This is the notes for page 1.2 of your Cornell notes. We're still talking about the structure of the body and how it is organized. And in this video, we're going to look at the characteristics of life and then how we maintain balance in our body. So the characteristics of life, this again is a review from biology, but to be considered a living thing, it must have these five characteristics. So the first one is organization. We just spent in the last video talking about how organisms are organized according to the different levels, starting with the cell on up to the organism. So having that interrelationship among the parts is one of those characteristics of life. So if something you're trying to consider if it's living or not, if it has organization in its parts, then that is definitely one characteristic. The second one, your first blank on these notes, is metabolism, right here. And this is your ability to use energy. So metabolism, as we'll talk about later in the year, is all of the chemical reactions that your body does to break down molecules and also to create molecules. And so that ability to use the energy to take in food and break it down for the purposes of your body is metabolism. So that's another characteristic of living things. The third is called responsiveness, where that particular organism can sense changes in the environment and make adjustments to that. And that's very important if you're faced with a situation and you're receiving information, a change in that environment, you're going to have to do something to make sure you survive. And so that's what responsiveness is. You also need to be able to increase in size. That's what growth is. And then development is your last blank here. These are changes in cell structure and function, maybe from very generalized to be very specialized. And at the end of the year, we'll be looking at reproduction and development, and it'll be quite fascinating for you to see, if you've never seen that, how all people start as this one little cell that develops and changes from something very general that you couldn't tell what it was to you. And so that's going to be pretty cool to see that. So again, all living things should have these five characteristics in common to be considered a living thing. Okay, our next section of your notes is talking about a little more detail on homeostasis. Up here we talked about responsiveness, your ability to sense changes and make adjustments to keep your internal environment what it's supposed to be like, to make sure you're at your most highest level of working. And so that homeostasis is the existence and maintenance of a relatively constant environment within the body. The pH of your blood, the amount of oxygen and carbon dioxide, and all of these things basically needs to stay at a constant level. And so even though we're not sitting in a bubble that's a constant environment, we're out about or outside, we're in interior environments, we eat and drink things that change our environment, and sometimes we have to do things to make sure it stays at that safe constant level. And that's what homeostasis is. So there are three main components to that. You have your receptor, which monitors the value of a variable. That's what's monitoring your environment. It can be your eyes, ears, nerves, all of these things that perceive things. That's your receptor. You must have a control center, which establishes the set point around which this variable is maintained. So the set point is kind of like, okay, you got to have your pH of your blood needs to be a 7.2. It has to stay that way. That's your set point. So there may be something inside that changes that set point, but that set point has got to be maintained by your control center. That's the brains of the operation, the control center. And then the effector is the thing that's going to change the variable. So if your pH is either too high or too low, your control center is going to have something happen to bring it back into its normal set point. So those are your three parts that must be there, that are there for any type of homeostatic mechanism. Now there are two types of feedbacks, homeostatic feedbacks, that exist in the body. The first one is a negative feedback system, and this is the most common type in your body. Most of the feedback mechanisms you have are of the negative type. So this is where your body will be told to stop doing what it's doing when something is going outside of its acceptable range. So when I mentioned the pH of your blood, or let's say the glucose level of your blood, it has a normal set point, but whenever something's going to be happening, something may happen to cause it to go too high or too low. And so negative means whenever there's a deviation from the set point, if it's too high or too low, then that deviation needs to be made smaller. Okay, and so that's why it's called negative, because you're going backwards from where it is now. You've got to go back to the set point, so it's negative. So body temperature is an example too, and then we mentioned blood glucose and also your blood pH. When it reaches the set point, it'll stop what it's doing. The whole goal is just to get you to the set point. So once you go back to your set point where it's supposed to be, whatever the control center is telling your body to do, it will stop doing it because you've gotten back to your normal range. So that's again why it's called negative. Now the positive feedback mechanism is kind of rare in your body. There's not a lot of situations where this happens, but whenever you have a positive feedback, the deviation from the set point, it doesn't go back to the set point. It just keeps getting farther and farther away from that set point. So if it's a bad situation, it's going to make it worse, which you're like, well, then why do we even have these in the body if it makes it worse? Well, there are certain specific situations that you have to have a positive feedback mechanism or you will never see the end of it. Okay, so an example, the two examples here, sorry, my screen keeps showing that, is blood clotting and childbirth. So think about your blood. When you cut yourself, you want your blood to clot to stop the bleeding, or you're just going to die of blood loss. So you want to keep going towards that point of blood clotting so that you can survive. Also childbirth. If you're in labor, and that's not a normal situation. That's a set point it's gone away from the set point, but you want to keep having those labor contractions so that you can get the baby out. If you stop, then you'll never have the baby, and that would be not good. Excuse me. So those are two examples, the only two examples of positive feedback in your body, where your body doesn't, when your body's doing something, it keeps making it worse in order to get to that certain situation to make it stop. But normally it's negative feedback. If there's a little bit of weird questions about this, we'll be talking more about this in our debrief day. But this is the end of your notes there. So let's look at a few pictures here. So this is again talking about homeostasis. So here's your set point. That's the level that it needs to be. So let's say body temperature as an example. So your normal body temperature is usually around 98.6 or so, give or take. So that's your set point. Now your temperature can exist in a range. Sometimes your temperature goes above the set point, but your body does some things to bring it back down. Sometimes your body temperature goes below the set point, and then your control center will get information about that from the rest of your body and do something to make you go back to the set point. So let's say you're very cold, your body needs to generate some heat. So your control center will send a message to your muscles to start shivering, moving uncontrollably. That movement causes heat to happen, and that brings up your body temperature. So that's something your body's doing to make you go back to your set point. If you're really hot, your body temperature is rising, you will sweat. Your control center, your brain, will tell your sweat glands to start producing sweat because the water, as it evaporates from your body, it will take the heat with you and cool you off. If you ever touch part of your body that's sweating, it's cool to the touch because the water is evaporating and taking the heat until your body temperature goes back to the normal set point. Here's another example of a negative feedback system where you've got your blood pressure normal range, but something happens to make your blood pressure increase that's disturbing homeostasis. So your control center in your brain is going to do something to make your blood pressure go down. It's going to receive information from the receptors. It's going to send the information to effectors, your heart muscle and your blood vessels. It'll make your heart beat slower, and your blood vessels will dilate to relieve the high blood pressure. So it decreases and goes back to your normal homeostasis. And the same can be said if it goes too low. Blood pressure decreases, receptors send information to your control centers. So it's going to cause the heart muscle to stimulate, blood vessels to constrict, and that increases your blood pressure and restores homeostasis. So this stuff's going on constantly in your body because we're constantly being exposed to stimulation in our environments. So now it's your turn. You're going to find this sheet. From now on, you'll see your turn pages will be in gray. So when you get to that, you'll know. You'll find this sheet in the file bin. The sheet has these word banks. On this half is the loop, so the feedback loop. So you're going to fill in the 4 spots. Here's your word bank based on what we talked about. And then the right side is the same picture, but you have different words. It's a specific example of the different parts of the feedback loop. So get this sheet out and use your book and notes to fill in these sheets in the word bank. As always, if you show me your attempt, you can then look at my book to see the answers to make sure you have the correct information. Go ahead and tape it to the top of the page. Leave some space on the bottom half of that page to the left of the 1.2 notes. We're going to be doing some things in there on debrief day. See you later.